From agave waste to valuable enzymes, scaling up inulase production for industrial applications. This is dedicated to Carmen Montiel Pacheco, our educational leader. As an institution focused on education and training, we seek enzymes for various applications. Our focus lies on agave, a native plant of Mexico, which plays a crucial role in the tequila industry. Annually, the industry discards 600,000 tons of bagasse and 500,000 tons of leaves as fertilizer. In agave, inulin is the main carbohydrate reserve, converted by exoinulases into fructose for sweeteners, bioethanol, and lactic acid. Endoinolases yield fructooligosaccharides, beneficial for gut health. Our project's goal is to upscale the purification process of the inoiso-3 enzyme to a pilot plant level, aiming for broader industrial implementation. Psychochemical properties of inulase. Its molecular weight goes from 50 to 80 kilodaltons. Optimal pH typically between 4.5 and 6.5. Optimal temperature from 45 grades Celsius to 60 grades Celsius. Substrate specificity acts on inulin, levain, and sucrose. Inoiso-3. Inulin is a linear reserve carbohydrate present in many plants. However, inulin from agave is a branched molecule, which makes it more difficult to hydrolyze. The enzyme inoiso-3 is an exoinulase, capable of hydrolyzing non-reducing terminal fructose residues of fructans. Inoiso-3 has a dimeric structure with a mass of 256 kilodaltons and a molecular weight of approximately 89.4 kilodaltons per dimer. Its electric point is 4.6. Diagram of the enzyme purification. Pichia pastoris is initially cultured in a medium containing glycerol peptone and yeast extract. After achieving high cell density, the culture is transferred to a bioreactor for enzyme induction using a methanol-based medium. In the downstream process, the induced enzyme is recovered through ammonium sulfate precipitation, followed by centrifugation and dialysis. Purification involves IMAC and TDA-NY affinity chromatography using buffers to remove salts, and the enzyme is stored in liquid form in 3HSL buffer for future use. The inulase enzyme purification process stands out for its sustainable approach as it drastically reduces waste generation and energy consumption through centrifugation and dialysis techniques that are energy efficient compared to other systems such as ultrafiltration and industrial drying, and also uses biofuel buffers and solvents such as sodium phosphate and 3HCl to reduce the environmental impact. In addition to affinity chromatography, continuous flow chromatography can also be considered, as it offers improved efficiency, speed, and scalability. It also allows large volumes to be processed quickly and efficiently, which will improve the purification process and increase the productivity. For long-term storage of the enzyme, freeze drying can be considered. This process preserves the enzyme activity and prolongs its shelf life by reducing water activity and preventing enzyme degradation. And freeze-dried enzyme is more stable and easier to transport, which facilitates storage and distribution. Normative. NOM 001 CD or electrical installations use in Mexico outlines safety guidelines for electrical systems in buildings and workplaces to prevent accidents. ISO 9001 defines quality management requirements to ensure products and services meet customers' needs, while ISO 70,025 species technical competences standards for testing and calibration last worldwide.